Life Management Science Labs would like to acknowledge that we live and produce this podcast on the traditional lands of the Wurundjeri people. We'd also like to acknowledge the traditional owners of the lands of our listeners and our international colleagues. We'd like to pay our respects to their elders past, present, and emerging. Hello, everyone, and welcome to Aging Less, the Longevity Science Insights podcast produced by LMSL, the Life Management Science Labs. We are champions of life management science, providing structured insights informed by science and inspired by practice on key aspects of conscious living. Each week, we bring you scientific and practical insights on each element with the expert knowledge of professionals in the field. I'm your host, Marie Stella, coming to your ears from Naarm, Melbourne, Australia. Let's learn together. Hello and welcome back to the show. An essential element of our environment, light plays a far more significant role in our lives than simply illuminating our surroundings. It's a powerful regulator of our internal clock, influencing our sleep-wake cycles, hormone production, and overall well-being as well. So in this episode, we'll delve into the fascinating relationship between light and our circadian rhythm, exploring how exposure to light, especially natural daylight, can affect our health. And joining us is circadian physiologist Dr. Jamie Zeitzer, who specializes in how light impacts circadian rhythms. Impressively, he received his PhD at Harvard and is now co-director of Stanford University's Center for Sleep and Circadian Sciences, where he is also a research professor of psychiatry and sleep medicine. So welcome to the show, Jamie. How are you going today?
Thank you so much for having me. Everything's going good. End of my day here, beginning of your day there, but all doing well.
Yeah, that's wonderful here. So before we begin, tell us a bit about what you do as a circadian physiologist. It's not every day that we hear that term.
Yeah. So honestly, I do a little bit of everything when it comes to circadian rhythms. I am hard pressed to stay on a single narrow topic within that, but we do a lot of work here looking at how light impacts the brain, how to optimize that. So thinking about how can we go about and getting people who are traveling, how can we get them over jet lag faster? For people who are working shifts, how do we get them more adapted to the night shift? About so many of us who have irregular schedules, how in spite of an irregular schedule, how can we keep our circadian systems healthy? And, this is something that a lot of people don't recognize or don't notice. These are long-term things. This is not, damage to your circadian system is not something that you'll see in days or months, but in more in years. So we do a lot of that. We do this with combinations of in-laboratory studies, field studies. We do computational studies. So lots and lots of different stuff to keep us busy.
Yeah. And all of this makes a whole lot of sense as well from an evolutionary standpoint. I mean, we usually, like in the past, not usually, in the past, we normally wouldn't have stayed up late at night for the entire night for days at a time. So yeah, that's a great introduction for our topic for today. Before we go further into detail about all of this, I would love to get to know you better. So this is Have You Met Jamie? And my first question for you is, what do you like to do in your spare time?
So I spend a lot of time with my family, wife, and I've got 3 kids, though one is sadly off to college now. So we spend a lot of time together, do a lot of hiking. And I my me time is on Sunday nights where I get to play volleyball.
Volleyball. Who do
Yeah,
you play volleyball with? Just yourself?
it's I do indoor sixes. We have there's a gym close by, and I get to play there on Sunday. It's pickup though. I've been playing with the same general group of people for about 20 years now. So
Yeah. Well, it's great to keep active.
absolutely, it's the first question my kids ask me when I get home is, what's hurting tonight? And I eventually say the list of what is not hurting is generally shorter.
Or I feel myself getting to that age.
Yeah,
um,
it's not that you can't do it anymore. It's just that it takes longer to recover.
Oh yeah. I don't. I can't say I look forward to that. I'm already seeing signs myself, and I'm under 30, so maybe I should start stretching more.
Well, good luck with that.
Yeah, thank you. I better late than never. I
Yes.
think. So are there any books or movies or TV shows that you enjoy?
Um, that's a good question. I mean, I try to read, but I have to say I do so much reading at work that it's hard to keep that piece of my brain still active at home. I do get some done, mainly um, in the sci-fi realm.
Mhm,
I just read Neil Stephenson's latest book, Neil Gaiman,
mhm.
things like that. Um, and sadly, I do watch probably too many movies. Um, every time my kids ask me about a movie, I say I've already seen it, which they're very
Wow.
disappointed at. But and then I like to say, well, I'm just I'm watching them, so I can give them good recommendations.
Oh, wow. Well, what would you say your top three movie picks are?
Whoa. Well, I gotta say my top pick is tough. It depends on the mood. Um, I do like Usual Suspects.
Mhm,
I think that's I love the twist kind of endings.
mhm.
So I really did enjoy that. Let's see. So that's going to be high on the list. For more artistic movie. Um, I don't know. I mean, I have to say it's hard to say because so many of the movies, it's just capturing the zeitgeist of the time, and I don't like rewatching it because
Mhm,
I've got like such pleasant memories. Like I saw Lawrence of Arabia when I was in college.
mhm.
Obviously, it was been out for a long time by then, and it was just brilliant movie watching that. But I would never watch it again because I have such a good feeling about that movie, having
Mhm.
seen it, 30 years ago. I
Mhm.
don't want to ruin that good memory. So
Right. Yeah,
yeah,
the nostalgia is not gonna hit the same.
it's
Uh,
not. It's not. So yeah. So a lot of movies. It's unless it's a bad movie. Like bad movies, I'll rewatch. But good movies, that's
That's so fair. I did hit you with a really hard question there, so maybe I'll rephrase. What movies have you enjoyed recently?
oh gosh. Not a lot. Most of them are pretty bad that I've seen. Um. Uh. Yeah. Yeah. Have not seen a good movie. I mean, I saw Oppenheimer several months ago. That was good. Not great,
Yeah.
but no, that was a good movie. I enjoyed it.
Mhm,
Um, and I mean, again, so there are movies. I just watched Inside Out 2 with the
mhm,
kids.
mhm,
I enjoyed that.
mhm.
It was a little too spot on in some places. Um, but so yeah, again, good movie. Enjoy. I mean,
Mhm.
so
Yeah.
the funny movies I get enjoyment out of. I don't know if they're good movies, but um, I do get that enjoyment.
Yeah. And what do you like in a movie?
Um, I do like good twists that I don't see coming.
Mhm,
That's always fun. Um, good acting. That's always helpful. Um, apparently anything with a British accent is just naturally good acting. I don't know why, but have that bias. So yeah, so I mean, yeah, I like language. My family and I really enjoy language
mhm,
and the use of it. So kind of witty repartee is
mhm,
always nice. We just watched the last season of The Diplomat
mhm.
and really enjoyed that. That was a lot of fun. Again, kind of that fast paced speaking style, back and forth. Yeah, so
Yeah, I can see why for sure. I mean, I love good dialogue in movies as well. I always find that it's a lot more realistic, just because the usual route of dialogue in movies is like very dramatic and one liners here and there, and it's just it takes me out a little bit sometimes. So when there's a huge chunk of dialogue that is purposeful, at least. Yeah, it's always a good watch. I enjoy Gilmore Girls for that reason. All 7 seasons, watched it. three times over, can't get enough. There's always something else to analyze, so that's always fun. But for a more general topic, is there anyone in your life that you look up to, either professionally or personally?
Um, well, personally, I kind of look up to my wife. She's amazing. The That she puts up with me, first of all, is makes her a saint. Um, and then, professionally, I've had several mentors, who I very much respect. Chuck Seisler, who's my PhD mentor, Emmanuel Mignot, who mentored me as a postdoc. But, one person who um, hasn't directly mentored me, but I've heard him speak many times, is Robert Sapolsky, who is a professor here at Stanford. And I have to say, I'm very jealous of Robert. He is not only brilliant, and brilliant in two different fields. He does work with, or did work with, molecular biology and mechanisms of stroke, and he also did lots of work on primate behavior. He's also an amazing writer. He writes, think pieces for The Atlantic, New York Times, places like that. He writes books. He is an amazing speaker. I will hear him speak about anything. If he's going to talk about how to brush your teeth properly, I will go listen to him speak. And he's just the nicest guy. So I'm very jealous of Robert. But I do aspire to try to at least get close in any one of those areas. So that, I have to say, is my kind of ideal. And oddly enough, I had met him many years ago when I was an undergraduate. My undergraduate advisor, Kate Sussman, was a postdoctoral fellow in his laboratory. So he had come out to the small college I was at, Vassar College in New York, and gave a talk. And when he got there, I don't know what I was expecting, but I was expecting, this giant of a person. And he's just, he's got this kind of this big afro, and he is just laid back and super nice California guy, even though he's from New York. And I'm like, no, it doesn't fit my image. But ever since then, I've just had, an amazing amount of respect for the man. So.
Yeah. Well, first of all, it's not often that I hear guests talk about how they admire their partners so much. So it sounds like you have a wonderful relationship. And second of all, this role model of yours sounds like a really cool guy to look up to. And I always think that jealousy is not the worst emotion you can experience. I think you can always channel that into admiration and to aspiration. So it sounds like that's what you've done, and that's great. So my last question for you is, what is a course or a class that you've taken that has stuck around with you to this date?
I don't know if there's a specific class. I mean, I have to say, the first class I took in circadian rhythms obviously had a major impact. It's not only did it in that one class, I learned about circadian rhythms, which I've spent the last 30 years studying. I also in that class, I met my thesis advisor, so that was important. And oddly enough, I met my wife in that class, so it was a very important class. So I don't know if it's stuck with me so much as it definitely changed the course of my life. And if you think about random events, had I decided to take another class, who knows what I'd be doing right now.
Yeah, for sure. Well, thank you so much for sharing all of that with us, Jamie. It's been such a pleasure to get to know you a bit better. So now let's move on to the interview. And for starters, how would you define longevity?
Well, longevity, I mean, simply speaking, is, how long, if we're talking about longevity in humans, how long will humans live? I think a lot of people are reframing it into more of a health span. So how long are not only we living, but how long are we living where we are healthy and active and able to do the things that we want to do? So I think that the health span definition is a little more appropriate in terms of how most of us want to think about longevity. I mean, if you're living to 120 and spend the last 20 years in a bed in a hospital, I don't see that much as longevity, as living longer, but so really kind of the health span view on it.
Yeah, for sure. And in simplest terms possible, what is the circadian rhythm? What is its role in longevity?
Yeah. So circadian rhythms are near 24-hour oscillations that are intrinsic to an organism. And they're incredibly important. And it's not just because I study them that I think they're incredibly important, but nearly every organism that has ever been studied has one of these clocks. So if it sticks around over millions of years of evolution, it's got to be important. So, and the critical aspect of it is it basically gives an organism, in our case, humans, an internal clock to know what time it is. And knowing what time it is super important to be able to predict changes in the environment. So if things happen at a predictable time, say when the sun comes up, or when an animal is at a watering hole, or when flowers open up, various kinds of events are very regular. They're predictable. But in order to be predictable, you have to know what time it is now, because many things require you to do things in advance in order to be ready for it. So for example, one thing that most of us do every day is wake up, right? And waking up is physiologically actually a very energetic thing. It takes a lot of energy to wake up. So in preparation for waking up, you actually start releasing cortisol, and that cortisol then releases glucose and gives you a lot of energy. So the circadian clock in that case is super important for guessing at what time you are supposed to wake up. Much in the same way, it guesses at what time you're supposed to go to sleep. Now, it doesn't mean you have to wake up then, or you have to go to sleep then, or you have to do anything, but it does prepare your body so it is more able to actually deal with these different processes. And so that's really the fundamental thing that a circadian clock is doing. There are other things that it does, that it's involved in. In other species, it's involved in things like seasonal behavior. So, when bears fatten up for the winter, it's not because it's getting colder, it's because their circadian clock is telling them that the nights are getting longer and they're able to respond to it. So super important to be able to anticipate these kinds of changes. And again, it's fundamental because it's stuck around for so long. In terms of longevity, circadian clock is really, I would say, it's very important for long-term changes in health and not short-term. So very rarely if the circadian clock isn't working, is there going to be a major immediate failure of a system, right? If you remove the circadian clock from an animal, they survive. They're not as robust, but they survive. They don't live as long, but they survive. So it's not like, oh, you take out the circadian clock and then the animal drops dead the next day. The heart stops working because it can't work without a clock. No, it works. It's just not working quite as well. So many of the things that it does are, subtle adjustments. One of the things that it's doing is that it's making sure that everything is coordinated, that everything is anticipating these kinds of big behavioral changes that are happening when you're supposed to be awake, when you're supposed to sleep. It's anticipating things like, oh, you're going to be active at this point, so let's get the immune system ready. So the immune system then moves cells that are necessary to the periphery so that you can respond to external insults, or let's move them internal so you can then deal with internal ones. So there's a lot of preparation that it's helping with. And again, this seems to be very important for kind of long-term health as opposed to short-term. So when you look at things like, cancer, like the more stable your circadian clock is, the less likely you are to get cancer. The more stable your circadian clock is, the less likely you are to get diabetes. Again, these are all less likely, not causal, but just less likely. And this is, again, going to happen over the span of years and decades rather than, days and weeks. Because really these are low probability things, not high probability. So again, if you have an erratic schedule, which will then lead to a weakened circadian system, and you do that for a week, that's probably not going to do anything. If you
Yeah.
do it for years, well, now you're buying a lot of lottery tickets, and you really don't want to win that lottery.
Yeah. And that just kind of reminds me about the lifestyle that night shift workers must be facing. How would you describe their experience there? I mean, I assume it's not from personal experience, but yeah, could you give us some ideas to how that would be managed?
Absolutely. So in night shift workers, we have the technical capacity to flip individuals so that they are alert and awake at night and can sleep during the day. However, it's not a functionally relevant capacity, because what happens is that it takes time to do that. It'll take you a couple of weeks to really fully flip, at least a week to fully flip between day and night. Typically, night shift workers are not flipping every week. They're flipping between days, because they might work 3 nights in a row, but then on their days off, they're not staying on nights. They're going back to being active during the day. They want to spend time with friends and family. So it makes sense that they're actually alert and active during the day and trying to sleep at night. And moving back and forth like that is not good for the circadian clock. And your circadian clock's in the wrong place. So when you do something like that, the circadian clock doesn't know when you're supposed to be awake, when you're supposed to be asleep. And so your nighttime performance is poor, your health gets poor, your sleep gets worse. It's not a very good combination. And so the circadian clock is really responsible for this kind of inability to shift immediately and just go and be now a night active person, and then the next day be a day active person. And again, these are things that if you spend a few nights awake, it's not good for you, but it's not specifically bad for you. Otherwise, I don't know if there would be a college student who graduates after 4 years without major medical disorders, because their schedules are so crazy. They might as well just be called night shift workers. So this is really a longer term thing. This is when people do this for years on end as a career, that it really makes things much worse.
And there's also a lot of talk these days about how technology with the blue light emission from screens and stuff affects our circadian rhythm. So, can you tell us about in what ways this artificial light affects our circadian rhythms, and what the potential health consequences are if it's really that big of an impact?
Sure. So there's a lot of talk about, light at night, especially blue light. The concern mainly stems from the fact that most electronic screens have a lot of blue light in them being emitted from them. And consciously, we don't perceive that as particularly bright. However, the system that transmits light information from the eye to the circadian clock is more sensitive to blue light. So the idea is that in this kind of light being in between the screen, it might not seem very bright, but it actually is impactful to the circadian clock. And under laboratory conditions, it absolutely is. Your system definitely has the capacity to respond not only to blue light, but to white light also at night, even the amount coming from your phone. However, and it is a big however, under real life circumstances, the light itself is not super important for most people. And the reason is that your brain doesn't look at this light as an absolute quantity. So it's not just saying how much light is there right now. It's saying how much light is there now compared to earlier. So if you've been outside, just to kind of put some numbers on things, a typical kind of bedroom, at least in the United States, and I think in Australia as well, is going to be somewhere in the 70 to 100 lux range. A bathroom, kitchen, office, that's going to be in the 2 to 500 lux range, depending on how well lit it is. Dining room, living room, 50 lux or so. Depending on how close you hold your phone to your eyes, it can be anywhere from 10 lux to 60 or 70 lux at reasonable viewing distances. If you go outside and it is cloudy and a gray day, it's around 10,000 lux. If you go outside and it's a nice, bright, sunny day, it is 80 to 100,000 lux. So it is orders of magnitude more light outside than anything that you get inside. So what people have shown is that when you are exposed to light during the day, you're comparing the light at night. And so basically, if you're getting a screen at night and it's emitting 50 lux, but you've been outside and in an office most of the day, and you've been getting anywhere between, say, 200 lux and 50,000 lux, I gotta say that 50 lux on the phone is just not doing very much to your brain. That being said, the light is enabling you to do something. You're not just sitting there with the light on, quietly contemplating life. The light is enabling you to do things, and many of the things that people are doing, especially when it comes to electronics, have been gamified in order to keep you and your attention on that device. So whether it is checking your social media, watching movies, television shows, these are all things that have been gamified to make sure you spend as much time as possible. Several years ago, Reed Hastings was on an earnings call, I believe, for Netflix, the CEO of Netflix. And he said on this earnings call, which is, I believe, still posted on YouTube, that their biggest competitor is sleep. And he wasn't wrong. That is he's wrong now. He's got bigger competitors. This was several years ago. But he is correct in that sleep is what you're competing against. And it's not that necessarily that people don't want to get sleep, is that they're replacing it with something that is usually pleasurable and fun. And so it's hard to convince people to do something else. So the light at night is important to me, mainly because it's enabling you to do something else. So you can put on all sorts of color changes on your screen. So it changes color. That's nice. It reduces the impact of light on your brain at night. It's really not going to do very much if you're still on your socials, still playing games, still, watching movies. It's really not going to do very much. Now, it might act as a reminder, and that's great. So I think of it as kind of like a reverse alarm clock. Your screen changes color and you're like, oh, that's right. I'm supposed to be going to sleep. It's 1 o'clock in the morning. And that's fantastic. So if that encourages you to go to sleep, that's very good. But the light itself isn't super impactful in a direct way. If you go to sleep and then wake up and then pull out your phone, that light is actually going to be impactful because you've just spent several hours in complete darkness with your eyes closed, sleeping, and now all of a sudden you've got this 50 lux of light, and in comparison, it's going to seem quite bright. And we've seen that kind of reset time, that kind of 4 hours reset time is sufficient to kind of sensitize the system. So now all of a sudden it's going to respond to that kind of light exposure and definitely wake you up. So I would definitely avoid screens with mid-sleep awakenings, like minimize the amount of light. So if you get up, go use the toilet, or you wake up and you can't sleep, definitely kind of minimize the light, especially the blue light that you're getting. But in terms of pre-bedtime, normal activity, I'd be much, much more concerned about what you're doing and how it's impacting you. So if you're doing something that's very exciting or very anxiety or more negative emotions, anything strong, positive or negative is not a very good thing to get you ready to go to sleep.
Yeah, I found that recently I've needed to stay away from social media prior to bedtime and just maybe watch a long form YouTube video or a TV show or something like that, and that helps me wind down a little bit better. But apart from that, there's also been quite a bit of discussion about amber light or red light and how it may help people sleep. So does the same thing apply there, or?
Yes. So the longer wavelengths of light, red light, amber light, if it's bright enough, it can impact your system. But it's at most light that normal people would be exposed to. It would definitely minimize that direct impact. Again, If you're going to wake up in the middle of the night and need light, then amber or red light is a much better kind of light to get. So if you need help navigating, to the toilet, having a amber or red kind of night light is a useful kind of thing.
Mhm.
And I know a lot of older individuals, this is actually very important to do because you don't want them falling on the way to use the toilet in the middle of the night. Ideally, they shouldn't be getting up at all to use the toilet in the middle of the night. But when people do, they need to be able to see their environment. That kind of visual input is incredibly important to your balance system. And so again, being able to see the environment, you want to minimize kind of its impact. We actually did some tests trying to figure out if there were specific wavelengths that you could give so that people don't wake up too much when they go and use the toilet. And unfortunately, in order to get the kind of the beneficial parts of the light for your balance, it also wakes you up a bit. So there's no real good way for an older individual to go and kind of navigate and use light and then not be slightly aroused from that light source.
Yeah, like even putting a nightlight or something like that might wake us up when on the way to the bathroom.
Again, if it's dim, it's not going to wake us up too much, but in older individuals, they need a bit more light because their light sensitivity is reduced because of ocular occlusions. Basically, not as much light gets through the eye to the retina, so you need more light. And they tend to be a bit more sensitive to that light in terms of it waking them up. And
Yeah.
the whole walking to the bathroom is going to wake them up as well.
Yeah. And with regards to jet lag and light therapy, your research showed that exposure to short flashes of light during sleep can help prevent that jet lag or alleviate the symptoms of jet lag. So tell us about how that works.
So that was kind of a fortuitous set of experiments that started that. A colleague of mine, Craig Heller, he and another colleague, Tony Vandenpoel, who was here doing a sabbatical, did this very weird experiment. And this was before I came to Stanford. And I am not sure why they did this experiment, and I've never gotten the real explanation from Professor Heller. Maybe one day he'll tell me the truth, but he did say that they just did this kind of fun experiment where because they had these extra mice and they exposed them to brief flashes of light, so like a camera flash. And so once every 60 seconds, the mouse got a camera flash. And they showed that if you just give one flash, it doesn't do anything to the circadian system. But when you give the sequence of flashes, it responded. And that's really weird. And so for many years, Professor Heller bugged me that I should do this experiment in humans. And I kept on telling him, no, this sounds ridiculous. But finally, he wore me down and we did this experiment and it actually worked. And then we explored it some more and we found that not only can you evoke changes in circadian timing using light flashes, but that they're actually bigger than the changes that you get using continuous light. So if you sit someone in front of a light for an hour, or you sit someone in front of light flashes for an hour, you get much bigger changes in circadian timing with the light flashes. And now, having sat in front of these light flashes many times, I can tell you, while we can do it in the laboratory, it's really annoying. Imagine if someone, flashes, a camera flash at you in complete darkness, every 10 seconds, 20 seconds, 30 seconds. It gets annoying really fast. You pay people and it's less annoying, but it's still not something that people would do. But what we found is that you can actually do these camera flashes while people are sleeping. And the flashes of light go through the eyelids when they're closed and into the brain and still change the circadian clock and do so without impacting sleep, which is the key thing. So the other thing to know is that your circadian clock is most sensitive to light while you're sleeping. So it's mainly not responding to light because you're sleeping and presumably in the dark and not getting much light. So what we found is that we can actually use these light flashes to manipulate the timing of your clock while you're sleeping and get very robust effects. So in a recent paper that we published, we actually showed that With this timing, we can get up to 6 hours of change in the circadian clock in a single night, which means that you can go to sleep, and when you wake up, your brain is 6 time zones away, which means that if you're traveling, you're pre-adapting for that travel. If you're in the US and you're going from the East Coast to Europe, it means that you fall asleep on the East Coast, you wake up, and your brain's already in Europe. And then you get on the plane and you arrive, and no more jet lag.
Yeah.
At least the circadian component. So that's something that we've been working on for quite a while. And what we've actually done with this now is we're actually doing this in teenagers, right? And so what we're doing is, so in teens around the world, there is a biological shift that occurs during puberty where teens like to go to sleep later. This is then compounded by various behavioral and social stressors and things that are enabling them to go to sleep later. So they tend to go to sleep much later. And despite the fact that they're going to sleep quite late, they have to get up usually quite early to go to school, often at 6 or 7 a.m. So the question is, well, how do you get them more sleep? So what we did is we actually gave these light flashes in an attempt to move their clocks an hour earlier. So basically move them a time zone to the east, so that when they were getting tired at, say, 1 o'clock in the morning, now when it's 1 o'clock in the morning local time, when it's 1 o'clock in the morning in their brain, it's only 12 o'clock midnight local time, enabling them to get more sleep. So we thought that this was a great idea. I spent lots of time, lots of energy, lots of money. We ran 100 people through it, and it was a total bust. What we found was that when you do this, you piss off the teens, right? We found a very complex way to make them quite angry, because now instead of being up late at night and fully alert, they were up late at night and tired, but they didn't go to sleep earlier. So, lesson learned, we combined it with a behavioral intervention. And when you do the behavioral intervention alone, which basically tries to convince them to choose to go to sleep earlier, you get around an extra 10 minutes of sleep per night, which is nice. But when you combine this light therapy during sleep, and it's nice, it's passive. Basically, we take a lamp that produces these flashes, we put it into a timer, we put it in their room, and then walk away. It automatically goes off at the right time every night. And when you combine that over a month, what you see is that they get 45 minutes of extra sleep per night. To me, that moves the needle. That means we're doing something if they're getting that much more sleep. So now what we're doing is we've shown that, we published on that, and that's over a month. So now the question is, a month is nice, but how about a year? What happens over the course of a year? So that's what we're doing now, is we're running teens through a protocol where we're seeing, okay, we're doing this therapy. They're going to get the light for the entire academic year. We're going to give them the behavioral therapy in the fall, and then we're going to monitor their sleep. At some point, do they just decide, nah, this is no, not happening. I'm going to sleep late. I'm done with this. Or do they actually find benefit to this? And so we're looking to see, is there a benefit to actually sleeping more if you're an adolescent? What do you get out of that? If you sleep more, we have all these theories about what should happen, but is this actually happening over the long term when you get this much more sleep? How consistent is it? Things like that. Do you perform better academically? Do you perform better in sports? Are you better in terms of emotion regulation, your family, your friends, things like that? So I'm very excited, but mainly hopeful that this actually will work and will engender this kind of long-term change in sleep in adolescents. So that's kind of how we're applying these light flashes.
Yeah. And do you envision that this may also extend to those who suffer from insomnia or circadian rhythm disorders?
I'm not sure how helpful it would be in individuals with insomnia or circadian rhythm disorders. In circadian rhythm disorders, their circadian clock sensitivity to light is not the same as it is in adults without circadian rhythm disorders or in these adolescents. And so they might be getting already light when they need to, and they might really need to get dark that entire time. And I'm not sure how useful a therapeutic intervention this would be long-term in these individuals doing it while they're awake. Because again, it is not the most comfortable thing to be in while awake. So I'm not sure about that. I do think that it could help some people with insomnia. There was a publication a few years ago out of Monash showing that some individuals who have insomnia are basically trying to go to sleep at the wrong circadian time. So it's really difficult to go to sleep in the hours before your circadian clock thinks you're supposed to go to sleep. This is fundamentally what happens with jet lag. You normally go to sleep at 11. You're trying to go to sleep at 11, but in your brain, it's only 8 p.m., and that's jet lag. Your brain at 8 p.m. is telling you to stay awake if you normally go to sleep at 11. And so in some individuals with insomnia, it seems like they're trying to go to sleep at the wrong time. And part of that might be is that they don't know what time they're supposed to be going to sleep because their schedule is too erratic. And so using this kind of device can help stabilize your circadian system because, again, it's a completely passive intervention, which is the key, because this is not a one-time thing. It's not like, oh, you get exposed to light flashes one day and then you're fixed for the rest of your life. No. This is every day while you're sleeping, you get this. Now, I should mention some people are very sensitive to light during sleep. We call my mother-in-law the human photon detector because if there's a stray beam of light anywhere in the room, she wakes up. This would not be an appropriate therapy. But most people are fine with some light in the room. And so, the question is, if you've got an erratic schedule, can this help stabilize the circadian system so that way, you can better anticipate when it's really time for bed? Then absolutely, that could help. And frankly, that could help more than people with just insomnia. That can help the many of us who have these erratic schedules. And once you have that erratic schedule, your circadian system is just weaker, right? This kind of light exposure pattern that you get with an erratic schedule weakens the amplitude of this circadian oscillation, and it makes it less impactful, which means it's less able to tell you when it's supposed to be day, when it's supposed to be night. And so for there, I think it can really kind of help people.
Interesting. Well, all in all, it sounds like it's a really exciting endeavor. So, yeah, I will be probably staying tuned. I do have some sleep issues sometimes, but let's not get into that.
Yeah, I would say most of us do. That's yes. It's.
Yeah.
I would say it is sadly the uncommon individual who can sleep just fine all the time.
Yeah, I think most of it is probably from the like you said, the excitement that you get from reading something or something that's going on in your life. And the good news is that we live in an age where all this information is also very accessible to the general public, so we have a better idea of how to manage that now. So on that note, what is a habit that you would recommend practicing in order to regulate our circadian rhythm?
Regularity. That's the main thing. And it's hard to do, but that is the best thing. And if you can't be regular, get as much light as you can during the daytime. First thing in the morning is the best, but if you can't do that, then during the daytime, that's second best. But that's really the thing that's going to, so again, regularity, that's great, but many people can't do that. Getting good morning light, that's again great, but again, not everyone can do that. And then as much light as possible during the day if you can. And I have to say, 15 years ago, 10 years ago even, I'd say these are all quite possible in most places. But you know what? Now there's a lot of work from home, post-pandemic, get a lot of people working at home. And many times when people work at home, they haven't adjusted their lighting at home. So they've got the same lighting all day long when they're at work at home. And then when they're at home,
Yeah.
they've got the same lighting. So there's no contrast. And this becomes a problem. So getting them out, with more and more, climate change and extreme weather events, people spend more time at home. Already before all this, people didn't spend that much time outside anyway. Surveys peg it somewhere around 6% of your waking day is spent outside, which is remarkably little time. So I think that one of the things that I and many, many individuals in the field are really looking at is how do we figure out what is the best kind of lighting in a built environment? Like, again, if you can live in nature, live in a natural environment, that's fantastic. Not everyone has the ability to do that. Not everyone has the access to do that. There are some people who live in more northern climes where that is not a preferable thing to do, in the winter. I don't think many people who live in Northern Europe, want to really start their day at 11 a.m. because that's when the sun comes up. So how do we then manipulate this kind of built environment, the lighting in the built environment, to optimize our health, again, in a passive way? Anytime you ask people to do things, even like, oh, you should wear these amber glasses at night. Okay, well, if that helps build up a habit, then that's great. Like, oh, I put on my amber glasses and then I wind down, and then I spend a little time reading, and then I get into bed and I go to sleep. If that builds up that habit, fantastic. But again, when you're asking people to proactively do things, sometimes they last a little while, but they're not. It's not a great way to engender these kinds of behavioral changes. So the more that we can do in the background without people having to actively change their behavior, and just kind of optimizing their biology through this, I think the better. Because again, there are many situations where we can tell people, oh, you should have a regular schedule. And say, okay, that's great. But, I don't have a regular schedule because family or friends or entertainment or work. So is it ideal? No, but it's life. And that's really the question, is how do we deal with real life and real life situations where people may not be able to do the ideal of, I get up at 6 a.m. and then I go for a 10-mile run, and then I come home and I eat healthy. Again, these are great ideals to strive for, but in the absence of being able to do that, how do we, adjust? How do we actually get people to do things that they actually can do and change their lives and health for the better?
Yeah. One in between that I've found to be particularly helpful, I think, is that instead of striving to wake up earlier and go outside, I just take the long route to work. So instead of like catching the tram immediately and just taking it all the way to work, I just walk a few stops, and then I take the tram from there and then get off earlier and I walk a couple more stops. And that helps to like at least get in some steps and some sunlight as well, without needing to wake up much earlier, which again isn't the ideal, but it's what most people can at the very least aim for realistically.
Absolutely. And to me, that's the key is, and that's something that we frankly do not understand well when it comes to sleep is, what are the trade-offs? So, if if you're not getting enough sleep, but you're substituting with something fun, you're not getting enough sleep because you're hanging out with friends and you're enjoying yourself. You're having a good time. What is the counterbalance? So maybe, not getting enough sleep is still bad for your metabolism, but maybe it's okay in terms of emotion regulation, because you've substituted that with another positive thing. And that's, again, when thinking about the circadian system with sleep, we struggle as a field to convince people of how important this is. Because if it doesn't work, you don't die. If it doesn't work, you don't get a disease the next day. You are able to function. And by far, the biggest effect of not getting enough sleep is feeling sleepy. And have a cup of coffee and you don't feel sleepy so much anymore. So it's hard to motivate people about this, especially when, try telling someone in their 20s, you know what, you should have a more regular schedule. You shouldn't go out to the pub tonight because in 40 years, you're going to have a small increased chance of getting diabetes. Okay. All right. Good luck. Again, I think it's very difficult to kind of engender the kind of behavioral changes that you want when that's the kind of timelines that you're looking at.
Yeah. Yeah. Well, I I need to reset. Sorry. Yeah, it's especially hard when different people function in their own ways. I mean, I personally cannot function I can't function very well on less than 8 hours of sleep. So I'm very like proactive with getting that regularity in. But yeah, I do know a lot of peers who do forsake a couple of hours of sleep for some screen time or some socializing time. But it is it well we can only hope we can only try our best to spread the news, and it kind of is up to the general public what they want to do with it. But either way, I do appreciate you sharing all of your expertise with us on this show today. Now let's move on to the open mic section. This is your chance to talk about anything that you're passionate about that doesn't have to be related to the topic. So the floor is yours. Please take it away.
Wow. Okay. Open my anything, huh? Um,
Yeah.
well, my New York sports teams aren't doing so well, so I don't want to talk too much about that. That would depress me. Um, how about this? How about my rosy vision for sleep and circadian rhythms in the future?
Go ahead.
All right. So it's not stuff that we can do yet, but I think that we're close, and I think that um, I am kind of pessimistic about the current state of wearables. Everyone loves wearables, right? Um, they've got their Apple Watch, they've got their Fitbit,
Mhm,
they've got their Xiaomi.
mhm,
There's millions and millions of these devices out there, and all of them, or most of them at least, will tell you about your sleep, and all of them are inaccurate, especially in people who are bad sleepers. So they're actually reasonably accurate in people who are good sleepers, but in people who are bad sleepers, these are for the most part not particularly accurate. But let's hold that aside. Let's just say they were 100% accurate. And they say things like, you had a bad night of sleep. Okay, well, that's not very useful. I know I had a bad night of sleep. I was there. Or even worse, geez, I thought I had a good night of sleep. Now you're telling me it's bad. Now I have insomnia. So their utility is quite low, right? Even if they were accurate with determining things like sleep stages and said, oh, you only had, 40 minutes of REM sleep last night. Okay. And, oh, and that's not good. And what am I supposed to do about that?
mhm,
So I do think that one of the things that will make these devices useful, A, is improving their accuracy, but B, is really contextualizing the information that they're giving. And I think this is something which can happen in the next few years, is really saying, okay, you have this device. It's not just telling you that you had bad sleep. It's telling you why you had bad sleep
mhm,
and what maybe the consequences of the bad sleep are and potentially how to fix it. So a simple thing is something like, oh, I've monitored your sleep now for months, and I can tell you that every time, it gets above a certain degree, a certain temperature in your room, you don't sleep very well.
mhm,
So I'm going to talk to your thermostat and lower the temperature, and we'll
mhm.
test it out. We'll lower it, see how that works. If that works, we'll lower it some more. If that doesn't work, we'll bring it back up. But let me play with the temperature to see if we can optimize the best temperature for you to sleep. Well, that's actually useful, right? Or if it says, according to your cell phone and the GPS on your cell phone, you are at this, at this restaurant, and every time you're at this restaurant past 11 o'clock, you don't sleep well. Now, I don't know what you're doing there. Are you drinking at the bar? Are you eating something bad for you? Are you working? I don't know. But every time you're there past 11, you don't sleep well. However, if you're there and you're home by 10, then you sleep well. Okay, now that's actionable information. So to me, I think that there is going to be a time in the not too distant future when the wearables are going to be integrated in with a lot of other sensors around us
Mhm.
and really give us an ability to understand why we don't sleep well on a particular night and what the consequences of that, what are those consequences and how to do something about it. Because right now, sleep is sadly one of these things and one of the few things that if you try harder, that actually makes it worse.
Mhm.
You know,
Yeah.
exercise, try harder. Okay, that's better. Studying, try harder. Okay, that makes it better. Sleep, try harder. No, 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 no. Do not try harder. Don't try at all. Just let it happen and it'll work. So it's one of these things that you need to have very specific information about what is and is not affecting your sleep. And usually we are not very good at identifying these long-term patterns. And that's where I think a lot of the wearables can really be helpful. And the other thing that wearables can do, and I think this is slightly longer term, is that sleep provides us a wonderful opportunity to monitor your health. And the reason I say that is because during sleep, you are either asleep in REM or non-REM or awake. If you're awake and not during the nighttime, you're behaving. And it is very difficult to know exactly what it is you're doing, and even harder, if not impossible, to know what it is you're feeling. So if I see this change in your heart rate or heart rate variability, is that because you're watching a scary movie? Or is that because you're having a difficult conversation? Or is that because you just forgot you left the oven on? Or is that just random and shouldn't have happened? Is this a totally appropriate response? I don't know. I don't know what you're feeling. I don't know exactly what you're doing. Very hard to track. During sleep, I know exactly what you're doing. We know what your heart rate should look like. And we know that that the idea is that you can pick up subtle changes in your physiology that are happening during sleep that might portend future changes in health. And so a colleague of mine has talked about this as precision health. So not precision medicine, which again has to deal with, which drugs affect you and things like that, but precision health. The idea is that it takes a long time to, let me stop, restart.
Sure.
So when you're thinking about precision health, one of the key things to understand is that current medicine, modern medicine, is really predicated upon a system of you get sick, and then when the symptoms build up enough so that they become intolerable, then you go to the doctor, and then you try to get it fixed. Well, the problem is in that build-up time, first of all, you may not have any symptoms, and then it may be a while before the symptoms become intolerable. And during that whole time, the damage is being done. And many times that damage is irreparable, right? You can't turn back the clock on that damage. So all you can do once you go to the doctor is stop future damage. So the idea is that during sleep, you can monitor someone's health, monitor their physiology in a very passive way, and look for subtle changes in their physiology that might indicate that their health is getting worse and which system is getting worse in. And then the idea is then you can do smaller changes. Now, the changes might not stop what's happening, but it might change the trajectory. So, for example, you still might get Alzheimer's disease, but instead of getting it at 82, maybe now you get it at 112. That's a pretty good trade-off. If what you're doing is you're changing the trajectory, you're not curing it, you're just changing the trajectory. And then the question is, when you do that, sometimes these trajectory changes, sometimes it does require a robust kind of intervention, and sometimes it's a lifestyle intervention. Sometimes it's you actually need to sleep more, or you need to eat better, or you need to exercise more, or you need to, do relaxation. There are various kinds of things that early on in the onset of a disease may be able to change the trajectory of that disease or even prevent the disease in some cases. Maybe much more benign kind of interventions than the very robust ones that we rely on now. So that is my vision for the future. And I think it is one that we will live to see if we live long enough, because I don't think that these are necessarily in the distant future. But I definitely see where our sleep will be unlike the sleep we've had in the past, in the sense that we will have passive monitoring of that to be watching our health, and as our health progresses, how we can then make these kinds of subtle changes.
Yeah, that's amazing. A great use of the open mic. So thank you very much for sharing that and for joining us today, Jamie. If our listeners want to find out more about you and what you do, where can they go?
I have a website that is, I guess, archaic because it's on the web and not on, Instagram. Um, but we do have a website for both the lab and for the center. The center is med.stanford.edu/CSCS, and the lab is sleep.sites.stanford.edu. I wish I could say that they're kept up to date all the time, but that is kind of giving you an idea of what is going on here. And
Well,
my students would love for me to actually get on Instagram, but as I told them, I'd rather keep my job. And my prefrontal cortex is not always on top of things, and I'd rather leave my spur of the moment comments to the home environment where they are not being recorded and saved for later.
well, that sounds like sound judgment to me. Thank you for sharing that. Thank you, everyone, for tuning in. We'll leave all of the details in our show notes so that you can access them. And yeah, thank you for tuning in. We'll catch you in the next episode.
You have been listening to Aging Less, the Longevity Science Insights podcast produced by LMSL, the Life Management Science Labs. More episodes are available from 10 life management perspectives and can be found by searching LMSL on Apple Podcasts, Google Podcasts, Spotify, YouTube, and other podcasting apps available on your devices. If you enjoyed this episode, please rate, share, and subscribe to our channel so that other people can find it and we can continue to provide quality content. More of our work can be found on our website at longevity.lifemanagementsciencelabs.com, where you can join our movement. I'm Marie Stella. Thanks for tuning in.